Today's topic is logic gates. So first we have to understand that what is logic gate. So actually we can call it the logic gate, actually the building block of the computer circuit. Why? Actually, if any device we try to implement, we can implement through the circuitry. So circuit uses the switch. Here to on and off the switch, okay, we need the logic gates. Through the switches we will give the input to the logic gates, and according to this input it will perform. Okay, so what is on and what is off? So we have to first understand. Okay, in Boolean algebra we have learned that computer only understand the binary information, that is 0 and 1. Okay, if you are switching on, then what information you are giving to the computer circuit? You are giving that the information is in the form of 1. If you switch on, then it will travels the information as 1. If you are giving if you try to give the 0, that is you have to press the switch off. Through the switch off you are giving the false value. The false value is 0 and the true value is 1. That is if you when you are switch on and you are passing the true value to this circuit. Okay, how many types of logic gates are available? Okay, first there is two type of, we can classify in two types. The first one is called the basic logic gate. Okay, the three type of gates are there, that is called the basic logic gates. That is, first one is NOT, AND, OR. These three gates are called the basic logic gates. Now the next one is NAND and NOR is there. NAND gate and NOR gate are called the universal gate. So why the NAND and NOR gate are called the universal gate, we will explain it in the lecture. Okay, so other two gates are there, that is XOR gate and XNOR gate. So depending upon the OR gate implementation, we can implement it. Okay, we need to take the help of the OR gate to define or implement the XOR gate or exclusive XOR gate. This actually the few symbols of the gate. Okay, when we elaborately explain the gates, you will come to know the which symbol is belong to which gate. So before the discussion of the explanation of the table of the gates, first we have to understand what is truth table. Truth table actually is a convenient way to visualizing the output. What output? Whatever input you are giving to the circuit, depending upon it, what output they will generate. Okay, so visualizing in a convenient way, so that we can understand that we are giving this input, depending upon this input the circuit will work like this. So this is actually called truth table. Okay, through this truth table we will check the condition. If it is true, whatever condition we are giving, it is true or it is false. Now come to the first gate. The first gate is called NOT gate. Okay, it is a single input gate. It means that through this gate only we can pass only one single input. Okay, and it is the most simplest logic gate. Okay, so it will take either on value or either off value. On value means what? On, and 0 value means what? Off. So see this picture, this is the logical diagram of the NOT gate. If you are giving 1, then it will give you the value 0. If you are giving the value 0, so it will give you the value as 1. So whatever input you are giving, it will just give you the opposite value. So that's why this gate is called the inverter gate. Now comes to the truth table. NOT gate truth table. See, this one is a block diagram or circuit diagram, what we can call it. It is A is the input and Q is the output. If you are giving 0, then it will give you the output as 1. If you are giving output as input as 1, then it will give you the output as 0. So every time it will give you the vice versa output. So if you 1, then 0. If you are giving 0, then it will give you the output as 1. Just opposite of the input every time. Next come to the NAND gate. Okay. NOT gate is having only single input, but NAND gate can take the multiple input. Okay, at least it will take the 2 input. Okay, and it will multiply the result of the 2 input and give you the final product. Okay, so through the truth table we will try to explain the functionality. So this is the symbol of the AND gate. So Boolean expression is what? A into B. So A in the A input, whatever value is given, that must be multiplied with the B input's value. Okay. So say B and 1 we have written. 0 into 0 will provide you what? 0 into 0 means 0. 0 into 1 is always 0. 1 into 0 is 0. And 1 into 1 is 1. So each and every cases this follows the multiplication rules. Next come to the OR gate. OR gate is also having the 2 inputs gate, but it will not multiply the input, it will add the input. So for that reason, only if any one value, in case of B or in case of 1, if any input is 1, so it will give you the true value. What is the true value? Is 1. Okay. So this is actually the logical symbol or block diagram of a OR gate. So if you are giving 1 in A value or B value, then you will give the value as 1. If you are in both the places, if you are giving 0, then you will give you 0 value. If both the places you are giving 1, then 1 value. For any of the 1 input, you are getting the value as 1. So truth table is what? If you are giving 0, 0 plus 1 is 0 plus 0 is 0. 0 plus 1 is 1. 0 plus 1 is 1. 1 plus 0 is 1. And 1 plus 1 is what? 1 0. You know that is 1 0. But here in the truth table, we will show only the 1. 0 carry we will not show over here. Okay. Next topic is the XOR gate. XOR gate actually mainly we are abbreviated the XOR gate, but is actual name is exclusive OR. Okay, exclusive OR. Just see the block diagram first. Okay, it is look like a XOR gate, but it's not the same as a XOR gate. Okay. First come to the truth table and find out the Boolean expression for it, then we will able to understand the truth table. Okay, the expression is A XOR B. This is a symbol of XOR gate. So what it is implement? It is implement that A bar B plus A B bar. Okay, so whenever you encounter a single one, I'm not saying for the 2 inputs one, I'm saying only a single one. Okay, or in that cases only you will get the output as 1. See, 0 and 0 is there, so that's why you are getting, no 1 is present over here, that's why you are getting 0. And 0 and 1, here you are getting a single 1, so that's why the output is 1. 1 and 0, single 1 exists, that's why you are getting the output as 1. But in 1 and 1, it means both the value are 1, you will not get the value as true value as 1. That's why we are getting the value as 0.